All right, well, thanks everyone for joining. I'd like to get started with the webinar. My name is Ryan Navarro, and I'm an applications engineer here at Hawkridge Systems. Okay, so the topic we're going to be covering today is SOLIDWORKS Weldments, which is a set of tools that's really useful for frame and structure design. And again, my name is Ryan Navarro. I'm an applications engineer here at Hawkridge Systems. So before we jump right into SOLIDWORKS, I just want to go over a brief overview of our agenda for this webinar so you can make sure that this is the proper thing that you want to be seeing. So we'll talk about what weldments are, some of the applications and industries or the ways you can use them, and then we'll have that product demonstration and some dedicated time for Q&A afterwards. So what are weldments? Well, they're a special set of tools within SOLIDWORKS intended really for working with frames and structures. So it can be a little bit of a misnomer because a lot of people think that weldments are only for welding things together, and that's not the case. We do have some good weld call-out tools that we can use in there. But you can really use weldments for any type of frame, whether there's welding or not involved. And it's available in every license of SOLIDWORKS. So it's even in SOLIDWORKS Standard, SOLIDWORKS Professional, SOLIDWORKS Premium. All the different flavors of SOLIDWORKS that you can get have weldments included. And the same thing with the sheet metal environment. What I found is a lot of people might not realize that these tools are there because they're on another tab of the command manager that you want to turn on. So this will reveal the weldments tools for you. So we'll look at how to do that. So I'm sure some of you are SOLIDWORKS users, maybe have dabbled in weldments or maybe haven't touched them before. So we'll see how to get things started there. And what the tool really allows you to do, the big power of the weldments tool is in the structural member tool, which really allows you, if you have a frame or any type of structure you're trying to create, it allows you to create a single line type of layout sketch here. So rather than trying to draw all the individual members, I just draw out the single line, kind of a wireframe of what I want. And then I can apply the appropriate profiles to that. I can choose what cross sections I want to be using and automatically apply those profiles to that single line layout. So that's the big power of the weldments tools. And why use them? Well, your complex joints and things where you have multiple profiles coming together, those are going to be able to be trimmed automatically based on your specifications. So that saves a lot of time compared to modeling those joints individually, modeling each tube individually. Cut lists are going to be automatically generated for you. So as you're building these frame structures, SOLIDWORKS is keeping track of the size of the profile and also the lengths that you're going to be using here. So when you go to create a drawing, you'll be able to automatically generate one of these cut lists for manufacturing. And it builds a very robust model. So you can go back and change out the profiles, try different tube sizes, different tube shapes, and also change the overall size of your geometry and have everything rebuilt and updated accordingly. Some of the applications or industries where people might be using weldments, you could use them on a very large scale for like architectural, structural type of geometry, I-beams and things of that nature, like the big plant layout we have here. The oil and gas industry will be using these a lot for their skid equipment. So when you have different processing equipment setting up these skids, so the actual frame of the skid here could be created with weldments as well as the protective railings. On a little bit smaller scale, machine design is a very popular use for weldments. So if you're building robotics equipment that has safety guarding around it, that can be one application, building the frame here. Building supports for equipment and different machines. It's a very common application of these weldment tools to create these type of frames. And it can go a little bit outside the box too. So things that are just made of bent tube can also be constructed using the weldment tools. So we have like a race car frame here on the left. Also some hand truck and some step ladders, things like that. You can also create using the weldment tools because again, we're just creating a line layout and then essentially sweeping the profile of our choice across that layout. And really it's the automatic trimming and automatic cut list generation that's going to really be saving us a lot of time. And then even more outside the box, we can even use weldments for things like woodworking. If you think of like a cabinet has a frame, right? This wouldn't be our typical everyday application of weldments, but you can create your own profiles as well. So you can create your own customized profiles, in this case for your woods, and then again do that single line layout of the cabinet frame and sweep those wood profiles along it. So really the possibilities are endless. It's when you consider creating your own profiles, it really opens the doors up to anytime you might want to be automatically tracking the cut length and automatically doing the trimming. You can do that with the weldments tools. So our application we're going to look at today is going to be this bus shelter. So it's one of those you might see at a bus stop to protect you from the elements there. So we'll actually switch over to SOLIDWORKS and we'll take a look at this file set here. So this is ultimately going to be our end result that we want to get to is a frame like this, okay, with different types of tubes set up. And we're actually going to start off from that single line layout sketch. So just so we can get to the good stuff quick, we're going to start from this layout sketch. But at the end of the webinar, I would like to show how we'll actually create a sketch like this as well. And this is created using a 3D sketch. So that's an option you have available to you in SOLIDWORKS. You can use 2D sketches, your traditional sketches and planes. But what you probably end up with is needing to create a lot of planes and a lot of sketches to create this type of single line layout. So the 3D sketch allows us to group all that into just one sketch or two sketches that are nice and easily adjustable. Okay. So with that 3D sketch there, I want to use my Weldment tools. And again, they're not visible on my command manager by default here in SOLIDWORKS. So I just right-click under my command manager, and I can turn on that Weldments tab of the command manager. And that gives me all these additional tools that I can look at here. And one thing about when you're working in a weldment is you'll get also a little weldment icon on your feature manager to tell you that it's a weldment. And you'll also get a cut list here, and this is where we're actually going to be tracking all that cut length information. So to get started, I'll choose my structural member tool, and that's what's going to allow me to actually assign the profile I want to these layouts here. And I have different types of standards I can choose from. And this is another thing, if you've dabbled with weldments before, you'll see these built-in standards like ANSI inch, ANSI, or ISO standards, and they have only a few different sizes in them, like square tube. You'll see if I choose a square tube, I have a couple different sizes, and I can select the line segment here, and we'll see that tube basically get applied and swept along that line segment. So that's the general idea of weldments. And I can go in and change the structural member to different sizes if I want to. But again, on a fresh installation of SOLIDWORKS, those sizes are a little limited. And you actually have a lot more sizes than that available. You just need to know where to get them. They're actually available through your design library over here if you click the little bookcase shaped icon and browse down to where it says SOLIDWORKS content and browse down right here to Weldments. You'll see actually these different standards, ANSI inch, ISO, these different standards, Unistrut. These are zip files that if you download and extract and add them to your file locations, it will open up a much, much larger library. So if we look at the downloaded files, you'll see I have many more different types of shapes, like S shapes, and each one has many, many sizes built into it. So I have really a lot of profiles here once you download and extract those files. And again, this is available in any version of SOLIDWORKS. So we'll see I can test out some different profiles here, see an L angle, could do like a T cross section if I want to. But ultimately for this one, we're just going to be using a simple square tube. So I'll go down to my tube square, choose the appropriate size I want, choose my 60 by 60 by 4, and we'll see that profile applied. And now the neat things begin happening when I select additional sections. So I just have that one leg selected, and as I click on another leg to add that, the two will automatically trim against each other. So you can kind of see that happening right there. And they actually have control over how this trimming is occurring. So I can choose one of the different end butt conditions here, or I can actually choose to miter those two together. So I have those controls over how I want them to be positioned. And we also have weld gaps that we can dial in, so you can actually have a weld gap right there between those joints. But the nice thing is I can just keep clicking around my structure, selecting additional line segments, and it will keep applying those corner treatments. And I can override individual corner treatments if I want to by clicking on one of these purple dots and then choosing to switch to a different condition. Okay. So as we're selecting these line sections, they get organized into what we call groups. So you'll see over here I'm in group 1, and I can click to create a new group, which is just a new set of selections I'm making, and click my way around the model, making sure that I'm getting those end treatments the way I want. So this is really how we'd use the structural member tool to generate these frames after using the layout there. And so far I've been positioning these tubes based on the center line. You'll kind of see they're being swept along the center line of this layout. But I'm not restricted to that. So if I want to, if I create a new group here and say I choose a tube like this, this one is being swept on the center line. It's landing kind of high on this other tube. It's going to get kind of a funky coping going on over here, if you can see that. So if I want to prevent that, I can reposition that tube. And I'll do that by coming down here and choosing to locate the profile. So right now it's located based on the center point. And if I click Locate Profile right there, what you'll see is that it will show me the sketch that's being used for that profile. So it shows me these different sketch points right here that I can click on. Right now it's set to the center, but I could choose to locate that based on the top point here, and then it shifts that whole section down. So it shifts that whole section down. So now my tube is going to be located flush with the top of my sketch segment. So you don't have to do any math and figure out how to offset that, because SOLIDWORKS is going to do that automatically for you when you locate the profile there. Okay. So again, I just keep making new groups and adding selections until I've selected everything that I want to use this profile for. So that's kind of the limiting factor. For one structural member feature that I have going on here, it's always going to use the same profile even for all these groups. So right now when I click OK, it generates all those different tubes. They're all trimmed against each other. If we zoom in here, we can see all that trimming action going on. And they're all the same profile. And it's also creating that cut list that's keeping track of all the different tube lengths. So at this point, if I wanted to, if I decided that was the wrong tube size, I could go back and edit that structural member feature, change it to like a larger tube, for instance, and I would see everything actually update automatically, right? So that's what I mean by swapping out the profile. You can go back and change the profile, and then I'll also undo that change there. So we have a question, why would you want to choose new groups instead of just selecting all the lines? You're actually forced to break down the selections into different groups. SOLIDWORKS likes us to select things either end to end, like I did these first groups here, or they need to be parallel. And really a lot of that has to do with the trimming. So the other reason you'll break things down into groups is to control the trim order. So you can imagine if you have a lot of intersecting lines, you need to kind of decide how they're going to be trimmed, and that's handled by the group order. And you can also override it by clicking those individual dots and changing the trim order right here. So there's a little more that can go into it when you get into the more advanced intersections. But in general, we just break it down into groups. It's just an easy way to manage and reorder those trim orders if we want to. And so now we have one structural member that's applied all those different tubes, and when I want to apply a different profile, I'll choose the structural member command again, and now I can choose maybe a different tube size. So in this case, I'll choose a small tube here, and I'll make some new group selections. And we can actually sweep the tubes along arcs. So if I select something that's a arc, it will allow me to sweep the structural member along there. Okay. And the one thing we'll find when we're mixing profiles like this, I'm using different structural members, is that the automatic trimming isn't going to happen anymore. So we're going to need to add in a trim step, but it's still going to be quite the automated process. But to show you what I mean, with this new tube size I'm selecting here, when I click OK, you'll see that it didn't automatically trim against the other member. So I'm going to need to specify how I want these things trimmed, because right now my tube is going right through the other tube. Okay, so we'll go and add one more set of structural members. I'm going to add a rectangular tube this time. And I'll choose maybe 50 by 30 by 4 here. And we'll organize these into some new groups. Okay, and we'll create a group running along the back. And you can align these differently if you want to. So my first group here, if I want to rotate those, I have control over the alignment and the angle. So I'll rotate that 90 degrees, and we can see that I'm able to rotate those independently from each other. I can also locate them independently. And again, when I generate this, because it is a different size profile, it's not automatically trimming. So if I do like a section view on this face, we'll see that there's a little bit of a gap, interference there, severe interference, right? So we want to add a trim operation to take care of that. Okay, so to do that, all we need to do is click on this Trim Extend button here. And actually, I'm done with creating new members here, so I can probably hide my sketch, my layout sketch, so I don't need to see that anymore. And I'll click Trim Extend. And this is a simple tool that allows you to select the bodies you want to trim, and then also the bodies that you want to trim against. So I can just select, for instance, these top arcs here, these 3 arc sections, as my bodies to be trimmed. And then down here in my trimming boundary, we can also trim against faces or planes. But in this case, it's easiest to just select the bodies I want to trim against as these other bodies. And if we zoom in onto one of these arced sections, you'll see we have a choice over whether we want to do a simple notch there to relieve that, or if we want to actually cope that against the other tube. And we also have choices here to specify things like a weld gap if we want to. We can specify a weld gap right there. Okay. So when I apply that trim, you can see it removes the interference right there. And I'll do the same thing again for the rest of my members. So I'll do a Trim Extend command once again, and I can select kind of all my cross braces I can select those all within a single trim feature. And then what I'll do is I'll select all my vertical sections within the trimming boundary down here. So I'll just go through and select all those vertical segments. So really, even though it's manual trimming, it's still a pretty automated process as far as we're not going in and doing a bunch of extrude cuts or anything like that. We're just choosing what to trim and choosing what to trim against. And here we actually have the control to keep or discard certain sections if you want to. So if you ever wanted to just remove some of these sections while you're in here, you could discard them as you go. Okay. And once I click OK, we can see that we have everything trimmed. And if I go back and revisit my section view, there's no more interference in there. Okay. So that's basically the basics of generating that frame. Now what I'll point out is the cut list over here, it's listing out all the individual bodies. So weldments are what we call a multi-body part. It's actually not an assembly file, it's a part file. So it kind of simplifies everything. And all I need to do here is either update my cut list or tell it to update automatically. And then it's going to go through and group these all into identical cut length items. So we can see any items that are identical, it's going to group them all together. So it finds these 5 pieces on the back. It finds these 2 pieces right here. And if we examine their properties, we'll see that SOLIDWORKS is actually calculating the length and the cut angle, if that's applicable, the material. You can have other custom properties here too that are stored with the Weldment profile. And the benefit of this is when you go to make a drawing, you'll be able to pull in something like this cut list table that will have the quantities of each tube, the descriptions, and also the actual cut lengths on each of these. So if you need a manufacturing cut list, it's going to be generated more or less automatically for you here. And as I talked about the robustness of this model, since it's based on that single 3D sketch here, we can go back to that underlying layout sketch and make any changes we want to the model and have everything update. So I'm just dragging out some of those dimensions and looking at the dimensions of my frame updating there. Okay, and I'll undo those changes. So the other thing I want to show here is that we can also mix our modeling methods. So this is all using Weldment commands so far, just using the structural member. But we have some other features here that are rolled back, and I'll just roll forward to show you those. So these are done more with the traditional modeling commands, the bench they created here, these little foot plates, for instance. If I look at those, if I zoom on in and edit one of these features, you'll see it's actually just an extrude. So it's a regular old sketch and an extrude. So just because you're using Weldments doesn't mean everything in your design needs to be using the Weldment profiles. You can mix and match Weldments and your traditional methods, and also things like Weldments and sheet metal can be mixed and matched as well. Someone asked, can custom profiles be created? And yes, certainly they can. The Weldment profiles are really basically just like a sketch, just a sketch cross-section that are saved back as a library feature. So there's really not a lot of work involved with creating the Weldment profiles. And if there's certain sizes that you want that aren't included in the SOLIDWORKS libraries, but they're downloadable from, say, a manufacturer, a lot of times you can download those manufacturer's files and kind of convert those into a Weldment profile. Okay, so we've mixed and matched some different modeling techniques here, and I just want to show some of the other smaller tools that are in the Weldments set of tools, like the Weld Bead tool and also end caps and gussets. These are just other time savers for you. Weld Bead is pretty powerful for documenting actual welds. Okay, so that puts the weld in Weldment here. When we click on the Weld Bead tool, it allows me to select different faces to weld between. So if I select 2 different faces of 2 different bodies, it puts a little line right there to represent the weld intersection. And I can turn on tangent propagation if I want that to go all the way around my part. And this is where I have control over how I want that weld to be. So I can specify if I want that to be an intermittent weld. I can set the gap and weld length, and adjust those. Okay. I can also control the start and end length if I want to. So if it's going to start from a certain offset, I can control that right here. And then we have control over the weld symbol as well. So we specify a radius, and then inside this option for weld symbol, we can control what type of weld we want to be using. And this is more for the drawing call out, right? When we create the drawing, we can pull in these annotations. And you have a lot of control here. And then if you're doing certain types of welds all the time, you also have the ability to save those back as a style. So you can save these particular weld types as a style and then reapply them. Okay. And ultimately, when I click OK, it's going to place in a couple of things. One is a cosmetic weld bead. So it's not actually real geometry it's placing in. It's kind of like the cosmetic threads we have. It's a cosmetic weld annotation. And it's also placing in the weld call out there. And to to easily propagate those welds across my part, there's an alternate mode to use this Weld Bead tool here where I can click Smart Weld Selection tool. And that gives me a little pencil where I can basically draw or kind of swipe over the areas that I want to weld. So once I have my weld settings dialed in, I can kind of just quickly swipe over the areas that I want to be welding. And in just a few seconds here, I can create something like about a dozen welds by just rotating my view and swiping over using that Smart Weld Selection tool. So that's a nice way to, once you have your settings dialed in, apply those things to the rest of your parts and bodies here. Okay, and then once I'm happy with that, I click OK. It generates all those weld callouts and annotations. If I don't need to be looking at those all the time, I can always toggle those off. And you'll also see we get a weld folder up here. And this shows me that particular type of weld, how many of them I have. And if I go to the properties on that, it's again keeping track of overall length and information for me. So if I want to put in a weld cost per unit mass, I can actually have it calculate an approximate welding cost for me. And you can have different callouts here that you're storing along with that weld information, again, to pass on to a drawing. Okay, so that's a nice tool. We also have dedicated tools, like I mentioned, for gussets and end caps. So if you're going to be adding gussets, rather than having to create a sketch, if you choose the gusset feature up here, this allows you to select different faces, and it will place a gusset in between there. So I can choose the size I want, dial up the size values, and I can also relieve the back of it if I want to here, so it doesn't interfere. So you can create a gusset and click OK, and it will place that gusset in. It's more of a direct applied feature for you where you don't have to create any sketches to do that. And we have a similar tool for end caps as well. If you have exposed ends of your tubes, like the one we have right here, and you want to have a cap or a plug for that, you can choose the end cap tool from your weldments. Just choose that end face, and then you can choose the corner treatments you want to be using here if you want to chamfer the corners, where you want that material to be added, and click the check mark to generate that. So again, you don't have to create any sketches. You can just apply those end caps onto your geometry. So that's about the essence of the Weldment tools for geometry creation. The next thing I want to look at with everyone is the geometry, the documentation creation, rather, of the drawings. And I just saw a question, is the gusset added to the cut list? Yes. Yes, it will be added to the cut list. So right now it's just listed as a body. If I update it, it'll become a cut list item. Okay, so it's getting added as a cut list item. And if you want to have more useful properties there, we do have options to automatically create like a bounding box. So create bounding box will actually replace the cut list item description with, something like a 60 by 40 plate for your gusset. So that's a useful option for you. Okay, and you can manually rename these cut list items as well if you want to make them a little more descriptive. So I can rename these as I want to. So as far as creating documentation now, I want to switch back over to our finished version here. And we're in a multi-body part, as a reminder, right? We're not in assembly. But we can still create exploded views if we want to. So this one right here has an exploded view in process. We can explode that. And we can use exploded views in multi-body parts. So you have one in process. And it works basically the same exact way as it would in an assembly. You just choose the individual bodies you want to be exploding and drag them out in the direction that you want to explode. Okay, so I'll drag them out in these different directions here. And we also have the auto space components after drag command in here as well. So if I want to, this bench, for instance, explode all those components, I can just box select them all, drag them down a little bit, and when I let go, it's going to actually explode out the rest of the way for me, all those little individual components. So I'm just creating this exploded view so that when I make a drawing, I can have callouts noting each component here. And when I'm happy with that, I can go ahead and collapse it and take a look at how we'd actually create a drawing from a weldment here. So I can choose Make Drawing from Part, choose my part template that I want here, and then I'll just add some orthographic views. So I'll drag in maybe a front view and project out a top view and also an isometric view. And I'll just want to change my scale a little bit so I have some more room to work with here. So I'll select that first view I inserted and change the scale on it to a smaller size. Then I can take that isometric view I placed in and tell that to be shown in its exploded state. Okay, so it's starting to look a little better now. I can change the display style for those if I want. And much like you can create a bill of materials for an assembly, in a Weldment drawing we have the option to insert something called a Weldment Cut List. So I can choose to insert a Weldment Cut List, choose my template, and click OK to insert that, and it's going to insert a list of item number, quantity, the description of each of these bodies, and then also the cut lengths for them. Okay, and just like a bill of materials, you can customize it, inserting additional rows and columns that are going to pull in different custom properties and tabulate them, multiply them, whatever you want to do. But we do want to have some callouts to this view to tell us which those item numbers correspond to. And I don't know if you're aware, we have the balloon tool where you can click on each individual body to place a balloon, and it will automatically inherit the item number. Or rather than doing that process manually, we have a tool called Auto Balloon, and Auto Balloon will actually place balloons all the way around your drawing. It allows you to choose different potential layouts for them, okay, depending on how you want your drawing set up. And it positions all these balloons on what we call magnetic lines. So when I click the check mark to place these, you'll see they're positioned on magnetic lines, which are these lines that I can move around and manipulate. I can drag balloons from one line to the other if I want to, so I could maybe reposition them as I see fit. So it just makes the manipulation of those balloon callouts a little bit easier. And this is, of course, present on our assembly drawings as well. And as far as adding length annotations, one thing I like to point out, if you're, I know in some industries it's difficult to dimension from center line to center line of the tubes. So one thing you can do here is, because we laid everything out on a single line layout, I can show that underlying layout sketch, and then I can actually dimension from those sketch center lines. So if that's something you're interested in, that's easy to do just by showing your layout sketch, and then again dimensioning from those center lines to get those center-to-center dimensions for the tubes if you're interested in that. And a lot of times you can import model items to actually bring over those dimensions from the part file as well. Okay. So that's the general process for documentation of these welded frame structures. The last thing I wanted to show as part of our core demonstration here is actually creating that single line layout sketch in the first place, and then we'll have some dedicated time for questions at the end. But the last thing I want to show again is creating that single line layout. So I'll create a new part here, new part file, and I just want to show you that the 3D sketching is really not difficult. So if I click 3D sketch right here, I have much the same tools as my 2D sketch tools that I'd typically be using in SOLIDWORKS. So my lines, rectangles, arcs, things like that. And I'll get started with the center rectangle here. And I'm just going to try to draw something kind of like our bus shelter frame there that we were working with. So I'll get started by clicking on the origin as my first point. You see I get a relation, just like a 2D sketch. And I can draw this out. And the difference in a 3D sketch is that I'm not sketching on a particular plane. So you'll see my cursor actually tells me XY right there. That's telling me that I'm sketching more or less in the XY plane. If I hit the Tab key on my keyboard, I can cycle through different planes here. So that's my YZ plane. I tab again, that's my ZX plane. That's like my floor. Okay. So we're not limited to just one plane anymore. And that's why to create these single line layouts, we don't have to create a whole bunch of extra reference planes or anything like that. So I'll choose the ZX plane right here, and I'll just approximately size that rectangle, and then I'll add some dimensions to it. So we'll make it maybe 60 inches wide and maybe 24 inches deep. And then normally in a 2D sketch at this point you'd be fully defined, but in a 3D sketch if I try to move it, it'll actually kind of pivot around and rotate about that point. Okay, so that's not what I want. I want it to be anchored down. So just like in 2D, we just want to add some relations. So if I click on one of these lines, just like my vertical and horizontal relations in 2D, I have just 3D relations here. So along X, along Y, and along Z. And if I look down at my little triad in the bottom left, I can see, okay, that kind of corresponds to my X direction. So I'll click this line and say along X, click this line and say along Z, and then I have a fully defined rectangle. And as soon as you have something fully defined, it's really easy to keep going in a 3D sketch now. So now I can use my regular old line tool and just start drawing up, and I can kind of auto snap what would be the equivalent of my vertical relation, which is my along Y on this part. And I'll just draw the 4 vertical legs of this frame. Okay. And what I'll do once I'm done drawing them, I'll select them all. So I'll just hold Control, select all 4 of these legs and make them equal. Then I can give them a dimension for my height that I want, maybe 72 inches. And then to build my top, I'll connect them with another rectangle. I'll just use the corner rectangle here, and I'll just go from one point tab to get to the correct plane and connect over to another point. And I just kind of need to drag and snap one of the points to one of my lines there to make it fully defined. Again, once we have that outline, now it's really easy for me to add any cross bracing that I want. I can connect from my midpoints or from whatever other points that I want here to create cross framing. So really the only challenge with a 3D sketch is just creating that first base that you want to have there, and then once you have that created, it's really easy to link to and connect the rest of those lines. So you'll see this is a little bit of a reinforced frame I created there. And then again, it has those dimensions, those key dimensions controlling everything all in that one sketch. So if I want to make any changes, I can change that and rebuild it and see the sketch update right away. So that's the neat thing about laying everything out in a 3D sketch. If that 3D sketch mode is intimidating to you, but you still want to get the benefits of it, there's a little alternate workflow I like to that I can show you, which is still very straightforward. And it revolves with just creating a 2D sketch, so creating a sketch on my top plane, creating that base shape that you want. So we could do the same thing, 24 by 60, and just extruding that up as a rectangle. So extrude it up 72 inches, same size as my other frame I just created. So I'm actually creating a boss extrude, an extrude feature. Okay, I basically made a rectangular box here in the shape of my frame. Then you can create a 3D sketch, and I can use the convert entities command. So I don't know if you've used that in 2D. That lets you pick edges and convert them into a sketch. And basically, if I just pick all the edges of this box I created and convert those in a 3D sketch, that's going to be the same exact thing as the other frame I created there. Except this time I didn't have to worry about managing those 3D relations at all. So I think using the 3D sketch is definitely the faster way in the long run. But this is a nice method to get you comfortable with it, is I can convert those entities, and I basically created a very identical 3D sketch here, where now I can go through and connect the rest of my lines, make the same identical shape I had before there. But I didn't have to worry about which plane I was in or anything like that, because the space extrude I created was managing that for me. And then I have the same great underlying 3D sketch, single 3D sketch. I have that body that I can hide to get out of the way. And then now I'm looking at the same type of frame that I can adjust. Right? So I can adjust these distances and everything just as I could with my other method. The only thing I have there is I have that lingering body behind. So if I really want to be diligent about getting rid of that, you would want to actually insert what's called the delete body command. Delete body. And that actually puts a feature in your tree that removes that. So now that body is actually no longer there, but I can still go and adjust my sizes. Okay, so that's just an alternate workflow for creating these single line layouts. And that's really the core part of my demonstration I want to go over with you all. I just jumped back to PowerPoint for just a second here. As a reminder, we showed you the Weldment Tools to generate these type of structural frames based on a single line layout, how it can automatically do the trimming for you based on the trim order and specifications you specify, whether it's mitered or end-butt. How we have some fast tools for doing weld callouts, adding gussets and end caps, creating documentation with the Weldment Cut Lists, and then also we looked at a little bit extra of how to create the actual single line layout sketches. And I just wanted to point out upcoming webinars that we have coming up. You just watched this one in the top left here, which is our Designing Frames and Structures with Weldments. At 11 today, we're going to have one on SOLIDWORKS Composer, which is for your technical documentation. And that's more of a tips. And I'm not sure if you're familiar with our format we're using now, but at every Wednesday at 10 a.m., we're doing a demonstration, which is like what we saw today. It's kind of a more fast-paced overview of all the features. And at 11 a.m., we're doing what we call product educations, which are more of a training style environment, a little bit slower, a little bit more detail on tips and tricks and things of that nature. So in the upcoming weeks, we've got webinars on flow simulation, SOLIDWORKS Electrical, CAMWorks, SOLIDWORKS Simulation, our analysis services group, which is our simulation consulting group, and DriveWorks for automation. So that's all I just wanted to point out that's available. And also these webinars should be available on our website as recorded webinars. So if you see a webinar you want to see but you missed it or you want to watch it again, you can always go on our website and watch those recorded webinars. So again, thank you for attending. And at this point, I'll kind of go back through our question log here and answer any remaining questions that we might have. So thank you all for your time. Someone asked if the presentation is available online. Yes, it certainly is. That link right there. Someone asked how to get to the explode command. That's a good question. It's a little bit hidden on a multi-body part. Let's see if I can go back over here and show you. This is the one that's finished. I already got it in place. So I typically would get to it. I would go to my configuration tab. So on your multi-body part, you click over here up to the configuration tab, and then right-click on your configuration. So right here where it says default, and I would say make a new exploded view. Click new exploded view right here. The other way you can get to an exploded view is to go to your insert pull-down menu. So your pull-down menu is up top on the screen here. Go to insert and then exploded view, and that will put you into the same interface where now I can start, clicking on individual pieces and pulling them away and building a new exploded view. It used to be that you need to have separate configurations for each exploded view, and that's not the case anymore. So now I can actually have multiple exploded views in just a single configuration if you want to. Let me just look back at our questions list here. Was the bench also made with weldments? That's actually a good question. Let's see. It looks like they made the base portion of it with weldments, and then the actual wood slats here were just a regular boss extrude. Someone asked about if we could make like a sheet metal roof for this thing. I can certainly show a little bit of that if we want to. It will treat it as a separate feature. So if I wanted to create a sheet metal roof here, using my sheet metal tools, that's another set of commands I can turn on sheet metal here. And I could create a sketch on the right plane. And I could draw out maybe an arc that I want to be using. So I could use a 3-point arc. And I believe we have some pre-recorded webinars on sheet metal if that's something that you're interested in. But the way I typically use the sheet metal tools is I draw kind of the cross section I want. I could draw my kind of flanges dropping down on the sides. Certainly you'd want to dimension these, right? You'd want to dimension all these sizes so they'd be exact. But for this purpose, I'll just kind of eyeball that there. And then once I have that profile created in my sheet metal tools, I'd create what we call a base flange. And this should allow me to actually extrude this whatever distance I want. So I forget how long we made this thing. Maybe I need to go quite a bit longer there. So I kind of dial in that length value until I get to go, to approximately the length I want. And we can actually apply the thicknesses and everything we want to be using here. So we could use a, a certain size steel, 16 gauge steel or something on here, maybe 10 gauge steel. Okay. Then when I click OK, like I talked about mixing different modes, right? I just created a sheet metal roof for this thing, and that's actually going to show up inside my cut list as another item. So again, I can probably turn on update automatically here. So I don't have to keep tracking those things. And you'll see that I have all these Weldment cut lists, and then down here I have a different icon that says it's actually a sheet metal cut list item. So that should also have different properties associated with it. It has our typical sheet metal properties like cutting length and things like that. Someone asked how to see the total length. Does sweeping affect simulation for stress analysis? Okay, so total length is an option on my drawing here. Let me see. Switch over my drawing. You can see it updated with my sheet metal roof I placed in there. So over here on my length, there should be, if I insert an additional column, I believe there is now a cut list property called total length. So right down here. It used to be you would just multiply the length by the quantity, and now they have a actual cut list property called total length that you can reference that will show you that. Okay, so that's useful if you want to be figuring out how much material to order. Where to save the custom profiles? Okay, so that's an important question. And these are things too that we would go over. We do offer a training course for Weldments. It's a 1-day advanced course. But the thing you'd want to look at is just in your SOLIDWORKS file options. So up here in your options, SOLIDWORKS has file locations. Okay, and this allows you to look at file locations for all these different things. Document templates. This is how you set up your drawing templates and everything, right? Down here, one of these types of things it's looking for is called Weldment profiles. And you can see I have quite a few different profiles created, but you just come down here and you click Add and browse out to the folder to place those in. I believe we have YouTube videos as well on how to do that. And can you create drawings for individual weldment components? Yes. Yes, you can. Different workflows for that. So if we're looking here at, this drawing, what I would end up doing typically is inserting a new view. Maybe I make a new sheet even. Okay, make a new drawing sheet, choose my template I want to be using. And then when I go to insert my drawing view, you have this option right here to select bodies. So instead of just placing the view, I click select bodies. It allows me to choose which body I want to be inserting. So like this tube right here, I just click on. And then I can place that tube in here, place my projected views from it. So it's just like, at that point, once you select the body, it's just like creating any other drawing. It's just kind of isolated that individual body there, and then I can add my dimensions and whatnot. So that's a pretty common request because a lot of times you'll need to detail out these tubes if they have holes drilled in them and things like that. Okay, so I can create as many sheets as I want to detail out all those bodies. Thanks for all the questions. We had a great turnout at this webinar. I saw some questions back there about regarding weldments with simulation. I'm not going to have the time really to dig into that right now, but that would be a great thing to, let's see if you can show us the webinar screen again. Yes. Would you like to see I'm not sure if you wanted this screen or if you wanted the very introduction screen. But if you have any more advanced questions and if you're a customer that's on support with us, please use our technical support line. So use this support email that you see right here or our support phone number, and we'll get back to you. But regarding the simulation, typically when you use the Weldment tools and then go to create a stress analysis from it, a simulation, it's going to simplify those weldments into beams. So it's going to simplify those into beams, and it will try to automatically create the joints for you. And it's, it doesn't always work. Sometimes you need to go in and clean up the joints a little bit. But you should always have the option to convert those into a solid as well if you don't want to be using those beam elements. How did I explode all the parts at once? That exploded view was actually in process. So it was actually in process when I switched to it. So there was a little bit of pre-done things there. When I dragged the bench out, for instance, though, if I go back there, when I went to do that bench explode, that was actually an option in the exploded view called, if I go back and explode here. Okay. When I exploded all those parts at once, that was an option called auto space components after drag, or in this case, auto space solid bodies after drag. So if we go back, I can always undo that step and show that again there. You turn on that option, auto space components after drag, and then drag a box around the components you want to explode. And then basically you can just drag them a slight distance and they will automatically space out by the amount that you specify. So how far those components space out. I believe this should be posted to our website typically within a couple days, this presentation. So if you want to review anything that I went over, that would be a good time to look back there. Okay, in just a couple days. Okay, so thank you all for attending again. It looks like I'm going to be wrapping up now. We did hit our time limit. So any additional questions, again, you can contact our technical support if you're a current customer. And just again, thanks everyone for attending.